You can go to the store and buy a RAID card, like a hardware RAID device, and then you can use that on your system and you'll be able to have hardware RAID. But Linux has a really awesome and powerful software RAID program that will use kernel level tools to allow you to create your own RAID devices without needing any specialty hardware at all. Now, there's a couple things we need to discuss, like partitions versus using raw devices. And I want to make sure we cover all the configuration stuff. But conceptually, it's really easy. Rather than having a hardware-based card, we just use our regular SATA controllers, and then our hard drives can all work together in a RAID array that we choose. Now, when I talk about partitions versus raw devices, let's say we have 200 gigabyte hard drives, but they're from different manufacturers. Now, they both say that they're 100 gigabytes. However, if you look close, they might have slightly different number of sectors and slightly different size. So this one says it's 100 gigabytes, but it might be actually 1028 megabytes. And this one says 100 gigabytes, but it might actually be 1022 megabytes. Now they round for marketing purposes, and that's perfectly fine. And usually on a system, it doesn't matter. But if you have like this drive fail in a RAID array and you need to replace it with another drive and you try to use this drive and all of a sudden, oh, you created a raw disk device RAID array unit and it has 1028 megabytes of space and you try to replace it with another 100 gigabit drive, but this one only has 1022 megabytes, you're not going to be able to work it because this isn't big enough. So generally what people do is you take and make a partition inside of your drive that is slightly smaller than the hard drive itself. So it might be 99.9 gigabytes. And then the same thing when you have a new drive, you're going to have enough room to create a 99.9 gigabyte partition. And so even though this drive itself is slightly different, the underlying partition is going to be the exact same size, so you're going to be able to use it to replace a failed drive in an array. So that's why we generally use partitions, even though using a raw device would work until you need to replace it with a smaller drive that is your replacement. Now here on our Ubuntu system, if we do lsblk, we're going to see we have 4 10 gigabyte drives that are installed in here. We're going to make a RAID array with those. This SDA1, this is our root partition. This is where our system is installed. But these drives down here are the ones that we're going to use to create our RAID array. Now I've already partitioned the first 3. You'll notice it's a 10 gigabyte drive and the partitions are 9.9 gigabytes. Awesome. We're going to do the SDE, the last one, together. And so fdisk dev SD and the first thing, well, we can press M to see all of our different options, but I'm going to go kind of quickly. I'm going to say O to create a new partition type, and it's going to be a DOS one. It doesn't have to be DOS, but I just decided DOS. And then I'm going to say N for a new partition, and I want the partition to be primary, so default, number 1, default, the start point on the drive, default. And here's where, rather than, if I choose default, it's going to be 10 gigabytes in size, and that would be fine as long as our replacement was the exact same kind. But I want to do it slightly smaller than the drive itself. So here I'm going to say plus 9.9 G and press enter. And now we have it 9.9 gigabytes in size. So any 10 gigabyte drive we'll be able to replace it with because we'll just create a 9.9 gigabyte partition inside. Now the one last thing, if we do T for type and press enter, it's going to say, okay, what partition type do you want? Here it says it created a new partition with type of Linux, but if we type capital L, we're going to see all of the available codes here. Now, this is not a format. This is just like a flag to give the kernel a hint as to what sort of partition this is supposed to be. So the one that we want to put on here is actually FD for Linux Auto RAID. So I'm going to type FD. And now it says change type of partition to Linux Auto RAID or Linux RAID Auto Detect. I'm going to press W to write this change to the disk. And now if we do lsblk, we're going to see we have all of them here. Now that partition type is just to give the kernel a hint. If you put these drives in a new system, it's going to say, oh, look at those partitions. Those are part of a Linux array or of a RAID array. So we're going to treat it as such. So it's just a hint, but it works even if you don't change that partition type. All right, so now it's pretty easy to create the actual RAID device. We're going to create a RAID 5 device with 4 10 gigabyte devices, well, about 10 gigabytes. And so we should end up with about a 30 gigabyte usable space with our RAID 5 array. Now the tool we use is mdadm. And then we're going to say -- create because we want to create a brand new one. I'm going to say verbose just so we can see it do things as we type it in. And now what device do I want to create? Well, the devices are dev MD and then the number of the RAID device you're creating. So we're going to start with MD0 because that's our first device and we don't have any RAID devices on here yet. I'm going to do dash dash level equals 5. I want it to be a RAID 5 device. And then dash dash RAID devices equals 4 because we have 4 devices. And now we need to list those devices out. And we're going to list the actual partition. So dev SDB1, dev SDC1, dev SDD1, and dev SDE1. We'll press enter. Boom, it created it that quickly. Now we can see the details of it if we were to look at proc md stat. This is the virtual file system proc, and this is going to show us the md stat, which is the current RAID arrays in our system. So here we have, it's currently a RAID 5 array. It shows our devices here, lots of information. It says recover, that's because it's building the array, but we can use it while it's currently using the array, which is really awesome. Okay, so we look into dev grep for MD. We're going to see there we have MD0. So we have a device all created and we can now use this as a hard drive in our system. Before we do that though, I want to save this configuration of this RAID 5 array into our system so that on boot, it knows exactly what sort of array to build. To do that, we just do mdadm detail scan. And if we do that, it's going to show us the configuration. So that's the configuration for our current array. What we want to do is save that. So I'm going to redirect it into etc. mdadm mdadm.conf. So we're going to save that result into this file. And now every time we boot the system, MD0 is going to be created. And then we just treat it like any other hard drive on our system. So mkfs ext4 dev md0, and boom, it created it. And now it's part of our system and it's going to be about 30 gigs in size. Let's see, lsblk. And we look down here, MD0 shows up as 29.6 gigabytes, about 30 gigabytes of RAID 5 storage on our system. If you're thinking that was a little bit too easy, well, you're right. Linux RAID is awesome. It's super simple to set up. It allows you to use the regular drives in your system and set them up as a RAID device. So as long as you can save that file into mdadm.conf, that detail scan that we did, and you can check for the progress or the status of your current RAID array in mdstat, you are really set. That's all it takes to use RAID on a system using nothing but software provided with the Linux kernel. I hope this has been informative for you, and I'd like to thank you for viewing.